Electez Design Suite, EDS, is electrical and instrumentation design software. It has three main modules, and this is a demonstration of the Electez module. Electez is a database-centric CAD application which can maximize efficiencies in the production of the drawings and reports required by electrical designers. Electez, today's topic, uses a CAD engine and a database to produce 2D deliverables such as schematics, single-line diagrams, wiring diagrams, 2D panel layouts, and reports. Instrument Manager uses an SQL database to produce loops, datasheets, and reports. And PanelDes Raceway is used to model 3D planned electrical and raceway systems, including cable routing. Electez Design Suite has been in development for 30 plus years and uses multiple languages and standards. Electez has been used by over 15,000 customers in over 50 countries. This slide shows a few of the EDS customers. Electez is built around a flexible philosophy, which includes smart tools, libraries, and templates, all used for increasing efficiency and accuracy in electrical design. For flexibility, we can use templates or typicals for any deliverables or any part of a diagram. Your company can choose exactly how your deliverables look. Databases allow an Electez team to use component-based data, enhancing accuracy and management. Electez users don't spend a lot of time typing or correcting repetitive component data. Your team can work concurrently on any Electez project, from upstream resources such as catalog databases to downstream reporting such as point-to-point wire lists. Electez integrates tightly with the other modules of EDS, allowing instant access to database data and 3D modeling, including cable routing. The integration reduces the chances of errors, double handling, and rework. Electez CAD tools include large symbol libraries and intelligent insertion, construction, and editing tools to help assemble your circuit diagrams. Electez provides propagation of component data between related components, duplication warnings, and easy component family and subcomponent management. All Electez component names are programmable. Electez will also check your component names against a set of rules. Electez has smart tools for editing the drawing data. You can do project-wide searching and replacement on new symbols, component catalog specifications, tag names, and any other text you wish to change. A component-specific database structure allows for fast data entry and efficient correction tools. Needless to say, the automated production of tables, cross-references, wiring diagrams, and reports represents excellent productivity gains for most designers. And just one more reminder, all of the libraries provided can be customized to suit your company's chosen policies and standards. I'll now briefly describe the demonstration I'll do today. I'll start off by creating some electrical schematics from within the CAD environment, followed by the production of a PLC I/O card. I will demo the fast data editing tools such as our global editor, and also demonstrate multiple circuit editing tools for speeding up the CAD environment. After creating the schematics, I will focus on downstream productivity and create cross-reference back annotations, use the navigation tools, and then I will create a refreshable CAD-based table. I will then show you the fully automated production of wiring interconnection diagrams, including terminal strips and device wiring. Finally, I will demo the reporting functionality, including a cable schedule, a point-to-point wire list, and a materials report. I will start the demo with a completely empty project. The project allows me to combine many thousand DWG files to be processed or edited together. I will use eBase to create a new project. I can use any folder and any project name. My folder is called C Drawings LV, and my project is called LV Demo. My project file name and path are displayed at the top left of the dialog box. I can select the working folder for my project. This enables Windows to provide me with a sensible default location whenever I open files. I will now close eBase and open an Electez session. The first thing I will do in my Electez session is save my drawing to a recognizable file name. In Electez, I can use any file name. The next step in my initial drawing startup is to add the DWG to the eBase project. I do this with the PRJ button on the left side of the Electez ribbon menu. My final drawing startup step is to insert a drawing border and title block. This can be done at any time, however a boundary is convenient during circuit drawing. I will choose a medium-sized border. The first circuit I will draw will be a three-phase bus diagram. I will start the three-phase macro from the Elecdes ribbon. On the Circuit Start Options palette, I can choose Orientation, Connection, and the start components in my circuit. I will choose a horizontal start with no connections. After choosing the start point on the drawing, I can select the next component in my three-phase circuit. I will choose 3-wire marker symbols. I will choose a wire specification from the Elecdes catalogue. The specification is detailed. A single part in the catalogue can contain data for 20+ attributes. The OK to All button completes the wire data, tag name and specs for all 3 wires. I will now select a circuit breaker for my bus. I will name the circuit breaker CB1 and choose its spec from the catalogue. I will choose the manufacturer Square D. There are many manufacturers and each one has many parts. You can filter the parts to make selection easy. I will choose a breaker with a 1000 amp trip rating. Note the amount of data shown in the spec on the right side of the catalogue is significant. My breaker has a family of subcomponents. Subcomponents are physical parts of the relay drawn separately in a schematic, for example, a shunt trip coil. I will now name the wiring downstream of my circuit breaker. To end my bus drawing macro, I can select End or choose a component that naturally ends the circuit, such as a motor. I will choose End and then select the option for No Connections to complete my bus. I will now create a three-phase motor circuit. This time I will start the circuit vertically with a 45-degree connection. I need to choose a start point on the center phase. The macro will repeat and redisplay the palette, and I will now select the circuit breaker. I will name the breaker CB21 and select a sample specification for it. Again, the palette is displayed. I'll just move this to the side and you can see how my circuit is forming. I will now select a contactor to control my motor. I will tag the contactor as K1 and select a spec from the catalogue. The spec I choose for the relay includes a family with a 3-phase power contact, 2 auxiliary contacts and a coil. Next, I will add 3 terminals to my circuit. The motor cable will terminate on these terminals. As with all Elecdes components, I give the terminals a name and then choose a spec from the catalogue. After the terminals, I will select 3 cable core markers. This will require the selection of a cable name and type from the catalogue. I will name the cable C1 and then select a cable spec from the Pirelli manufacturer. I will choose a 3-core cable. My final selection from the palette will be the motor. Elecdes knows that the motor will terminate the circuit, and so this will be the last component I select. I will name the motor M1 and select a sample spec from the catalogue. This completes my motor circuit. Elecdes has added electrical intelligence to the CAD session. The CAD session will now react to the copying and pasting of a component in a smart manner. When I copied the circuit 4 times, the names of all of the components will be incremented in a circuit-sensible manner. Without the Electez circuit reactors, you would need to click on each component in wire and retype any duplicated tagging. There is still an issue with the copied circuits. It's highly likely that we will need to change the spec of some of the components. For example, the breakers may need to go up or down in size, and similarly, the cables may need an upgrade. We will do this with the global editor later. So far, we have used an Electez macro to draw your circuit. Electez also has many simple drawing and drawing edit functions. I can, for example, use Electez to clone any circuit component. Electez allows me to easily change the orientation, tag name, and the spec of that component. I can easily move components with line breaking and repair being fully automatic in Electez. I can quickly reverse any component symbol. For electrical designers, a common need is to modify component specifications, often for multiple components. I can use the Electez Global Editor for this. In this case, I will edit my 4 circuit breakers. I will firstly renumber the 4 breaker tag names. I will decrease them by 10. CB21 becomes CB11 and so on. This is far quicker than clicking on each component's attribute and retyping it. I can quickly change the catalog specification of the 4 breakers by choosing another manufacturer and a 32 amp part. Note, catalog reselection changes up to 20 attributes per device, including part numbers, terminal numbers, ratings, and subcomponent family structures. After global editing, I save my changes and the drawing is updated. With Electez, you can global edit a single component, any part of a drawing, a whole drawing, or even a whole project containing thousands of drawings. Next, I will use another Electez macro. This time, I will construct a simple ladder. I can adjust the run count and spacing. As with all Electez macros, the circuit is assembled with line segments for wiring and our smart Electez components. After creating the ladder, I can select and insert components on that ladder. Firstly, I will place a terminal on the circuit. I can choose the terminal style from a palette menu and then position the terminal on my ladder. I'm then asked by Electez to supply a tag name for the terminal strip and to supply a terminal number. Electez uses this data to identify the terminal and to group together the terminal strip's family of terminals whenever required. The terminal is inserted into the wire at the chosen point. I'll now make a copy of the terminal. Electez assists with the copy by determining the orientation, breaking the lines, and providing the next available terminal name. Next, I will place a float switch on the circuit. Again, I choose the switch symbol from a palette menu and then I position it on my ladder. Electez requests a tag name for the float switch. By now, you will have learned the process for placing any Electez component with 4 simple steps. Step 1. Choose the symbol. Step 2. Position the symbol. Step 3. Enter the tag name or identifier. And Step 4. Select the spec from the Electez catalog. I will name my float switch FLS1 and use the sample part number as a placeholder. Once I press OK, the symbol is inserted in my circuit. As this switch is in the field, I will now place 2 cable core marker symbols in between the float switch and the terminals. I will name the cable CFLS1 and make this conductor the first core. The cable type will be a single pair cable made by Pirelli. I will now position the second core from that cable. I will confirm the cable name, spec, and the second core name. The Electez name sequencer is a program which assists with creating the tag name identifier for all components. Most of the time, you won't need to enter a tag name. I can now replicate my field device circuit with the CAD copy command. You will note that the Electez reactor system automatically manages and increments the tag names to the next available names when we copy Electez components around the circuits. Electez also provides a name synchronizing system which ensures families of symbols and duplicated symbols are kept synchronized when you edit them. Another method of symbol insertion is the inserting of subcomponents for devices in the project. In this example, I will insert a coil from our motor contactor K1. After I insert the relays coil, the family list will be redisplayed, showing me the family members or subcomponents of that relay and their availability. I will also insert a normally closed contact on the fourth rung. I will repeat the insert process for the other three relays, inserting their coils and their normally closed contacts. The Electez system for managing subcomponents is extremely useful when managing complex protection control relays for larger equipment and higher voltages. When tasked with drawing up a protection and control relay with 30 family members and 60 terminals, it pays to be accurate and to manage your contacts' terminals. Without Electez, these types of relays are managed manually, and errors will be highly likely and will cost both production time and rework time. Another fast method of symbol insertion is inserting directly from a catalogue. In this example, I will insert a protection relay for a circuit breaker. I'm going to use a Schweitzer protection relay from the Cell 315 family. This relay is complex and specifically for managing large circuit breakers. When you have lots of data in your catalogue, a filter will reduce the number of items in your list and make the process easier. Note, the Cell has over 30 family members. It's difficult and time-consuming to manage this device manually. I'm going to insert the auxiliary power supply subcomponent. I will place it on rung 1 and name the relay R1. I can add a simple earth connection to the auxiliary power supply. This entails a simple line segment and earth indicator symbol. The earth indicator symbol is found on the reference and indicators palette, which is provided for non-component symbols. I typically insert a terminal on an earth symbol to allow for an earth bar termination in my wiring. The next step of the process is to add subcomponents from R1, my relay, to the ladder. I will insert two input subcomponents from the relay R1. These inputs will tell the smart relay that the load is on the breaker. Note, I don't need to pay attention to the terminal numbers in use or the family member function. Electez manages that for me. I will insert two contact outputs from the relay R1 onto rungs 2 and 3. These contacts will be used to trip the breaker if R1 uncovers a problem and needs to open the breaker. I will now insert the trip coils from the main breaker to my ladder on rungs 2 and 3. Firstly, the shunt trip coil, and then the undervoltage trip coil. The global editor can be used for many different edit tasks. You can reselect components from the catalogue, you can renumber your wires or tags, and you can find and replace information throughout the dataset of the project. All of this can be done at a very fast pace. I'm going to demonstrate a simple edit done with the global editor. I will simply highlight the trip coils and add some text to each in the visible description attribute. This is a simple and efficient process when you have multiple attributes needing change within your circuit. This also works within raw text on the drawing. The last items that I will manually place on the ladder are wire extension markers. These markers are special in that as well as labeling and speccing a wire, they can jump across circuits, sheets and files in your project. I can select the extension markers directly from the Electdes Symbols menu. I will then position the marker. This is the smart symbol that can be inserted with a connection at either end and can be oriented horizontally or vertically. Like all Electdes component symbols, the component needs a tag, in this case a wire name, and it also needs a spec from the catalogue. I will repeat the insert process for a normal wire marker. Electdes has an automated system for placing normal wire markers on a circuit. When I run the wire marker insert function, I can either place single wire marker symbols on the conductor lines one by one, or I can select a window of conductor lines to mark with wire markers. I will choose a window. I will save the current drawing so Electdes can assess which wire markers are available and which have been used already. I need to set the first wire name and choose a catalogue spec for the wires in my selection. Electdes spaces the wires at a set distance from the nearest termination. Electdes can also insert space saver markers drawn on leaders when space is tight. My first circuit is now complete and I will save it. I'll also save it as a new name, creating a second sheet for my project. I will call this drawing LV Ski 2. I will global edit my second sheet in its entirety to ensure I have not duplicated tag names. Firstly, I will edit the Devices class. Devices include electrical components such as motors and circuit breakers. However, devices do not include terminal strips and conductors. I will sort the components by tag name. After that, I will select all items in the list. I will now use the increment-decrement function to renumber all my component tags. Renumbering tags is necessary to avoid duplication. I will increase all of the device tag names by 20. This renumbering tool saves a lot of clicking and typing in the CAD environment. I could also at this time change the specifications of these devices in the new circuit using the Reselect from Catalog tool. I will now switch the global editor to Cables mode. This allows me to rename and reselect the cables on my second drawing. I will also increase all of the cable names by 20. Again, I won't reselect the spec for these cables. I will now switch to wire editing mode. I will renumber the wires. This bulk renumbering and renaming makes revisions easy to implement. To finish off my second circuit, I will switch to terminal editing mode and renumber the terminals. Although there's a lot more functionality available in the global editor, including other classes and other attribute change tools, I've only made the necessary changes that avoid tag name duplication. I'll now save my changes and exit. If we look a little closer at the circuit, I can see hundreds of changes to the tagging on my circuit. Normally this would be hours of work. There are some items in the circuit that do in fact need to be duplicated. For example, the wire extension markers. They need to mirror the wire continuations from my first sheet. As a comparison, I will use the simple CAD command attribute edit to edit these symbols. This is the tool used when you don't have Electdes. I will need to click on the symbol, then click on the attribute, and then retype the data. I will now save my second drawing file. I need to add it to the project. I'll use the ribbon menu button. Electdes can automatically cross-reference your circuits on a project-wide basis. Cross-referencing is done by capturing the position coordinates of the components and then assigning them a named zone on the diagram. The zone could be a grid square or a rung number rectangle. Cross-referencing of families of subcomponents often requires a table to be positioned and created. I'll insert a table header. A table header needs to be linked to a component for the family that needs referencing. I will select the relays K24 and K25. I'll position the headers in some space on the side of my sheet. I'll select the cross-referencing tool from the ribbon menu. The cross-reference tool asks me which components and tables I wish to reference. This enables surgical selection of the items to be referenced. I'll include the wire extensions and relays K24 and K25. Zooming in on the complete cross-reference tables, I can see that the relay family is tabled and referenced project-wide, including spares. Similarly, the wire extension markers reference the other end of the wire. The reference style used here is a two-dimensional map style grid where A is the first row and 1 is the first column, like a map or indeed my drawing border. This reference style also includes the sheet name. Elecdes has a project-wide navigation system. You can simply pick a component and jump to its other references. I'll choose a wire extension and jump to the other end. The navigation tool opens the drawing containing the other reference, zooms in on the component, and then highlights a reference with an arrow. Navigation is, of course, bidirectional. The Schweitzer relay has many subcomponents in its family. To navigate to it, I can enter its tag name, R21, or select any subcomponent symbol. The navigation tool will only display the subcomponents that are in use in the project. It would be difficult to jump to the unused family members. I will navigate to the contact marked Output 101 with terminals marked A1 and A2. Navigation is not restricted to components on your current drawing. You can enter wildcards in a search. I'll search for any items with a tag name of W star. The asterisk is a wildcard meaning anything. The tool will search for all components and conductors with a tag name starting with W, and I can then double-click on any component to navigate to it. I'll now set up a third sheet and demonstrate the PLC card generator tool. The PLC tool allows you to create a file containing the card configuration, including the card, inputs and outputs, wiring and terminals. In the first step, I will choose to edit a card that I have already configured. I must pick the file containing the card configuration. In the first page of configuration, I can choose the card tag name, panel and its first address. I must select a card type from the catalogue. There are many manufacturers and card types supplied in the catalogue, and you can easily add your own too. Finalising the addresses and I/O descriptions can also be done from the first page. I'll type a few demo descriptions in. I can also choose the I/O circuit macro for each I/O. This can be one of the standard supplied macros, or you can make up your own I/O circuit macro. I've chosen a simple limit switch input macro. If you have chosen I/O circuits that contain wires, cables, terminals or devices, then the PLC tool will request the tag names and specs for those components. To save time, I won't change these values. Once I've completed configuring the card, I can save the file. I will now run the PLC tool again. However, this time I'll select the option to draw a card. I must select a PLC card configuration file, such as the file we just edited. Prior to the card being drawn, I must supply inputs such as the orientation of the card, which I/Os to draw, if I am splitting the card, and the side of the card on which I will attach the I/O. I will make the card vertical and split my 16-channel card after channel 8. I will position the first part of the card on the left side of the sheet, and I'll position the second part of the card on the right side of the sheet. After I've drawn all of the parts of the card, I can cancel out of the PLC tool. Note, the card is still templated by the configuration file, therefore I can use it again. Let's now examine the card I've created. The card has multiple wiring macros in use on the two parts. The I/O addresses, descriptions and card terminals are all set. And the wiring, terminals and field devices are all tagged accordingly. Just a quick note, the Elecdes PLC tool can be customized to suit your needs. You can add card types, manufacturers, I/O circuits, and of course you can substitute your own symbol, colors, layers and graphics. For the next part of the demo, I will create a wiring diagram, a great tool for wiring your panels, devices and terminal strips. Wiring diagrams give you a list of all of the relevant wires to terminate, plus the terminals to connect them to and a diagrammatic position for each terminal. Firstly, I will create a new sheet with a new file name, add it to my project, and then insert a border. Due to the large volume I plan to include in this diagram, I'll use a large size border. I will start the wiring diagram tool. This displays me a list of all of the devices and terminal strips in the project. I can filter by enclosure if I wish. I need to select the checkboxes alongside the devices I wish to draw. I'll select the terminal strip, the PNC relays, and a couple of the small relays. After I select the Create button, ElecDes will ask me to position each device. I'll place the control relays on the left, PNC relays below, and the terminal strip on the top right. It is common strategy to lay out the devices so they mimic the panel rear view or wiring view. The front page of the wiring diagram generator has quite a few layout preferences which you can set to suit your needs, such as orientation, mirroring, and selection of templates. The wiring diagram generator has many custom settings in the preference pages, allowing you to create a diagram exactly as your standards require. You will note that the terminal strip contains all of the cabling, wiring, and jumpers. This diagram was assembled from many sheets of schematics. The Schweitzer protection control relay is extremely complex. Having a single explicit diagram to define its wiring is a big efficiency gain compared with wiring from 20 schematics. Historically, a manual wiring diagram takes about the same time to collate and draw as a schematic, hours or even days. Then if a revision occurs, the wiring diagram rework will take a similar amount of extra time. Errors often occur when manually synchronizing wiring diagrams and schematics. ElecDes wiring diagrams are fully automatic, sync error-free, and take seconds to create, not hours. They're 100% refreshable, so revisions cost nothing. Companies using ElecDes get all of the benefits of wiring diagrams without the costs or lost time. For the next part of the demo, I will create a live materials table. This is used to transfer materials information to CAD in a tabular form. The first step involves selecting the data file which contains the material data. I need to select the columns that are to be displayed, such as tag name, part number, and panel number. Now I need to set the table spacing and format. I'll start by setting the text height for all table text. Now I will set the format to include border lines on all columns and also on the title row. I know that the catalogue description and reference columns are longer than the default, so I'll make them larger. If a column overflows the spacing, the text will automatically wrap. I will also extend the column width on the manufacturer column, which contains the manufacturer name. This could also be quite long. I can limit the rows allowed on the sheet by including a panel filter or by fixing the first and last rows. I'll now press OK and position my materials table on the sheet. The materials table is now drawn. The table is both adjustable and refreshable. By adjustable, I mean that I can edit the table at any time and adjust the contents, format, and layout of the table. To demonstrate adjustable, I will edit the table and increase the column width for the tag names. And by refreshable, I mean that if my data changes at any time, I can simply press the refresh button and the table will be redrawn with the latest data. eBase also contains an option for refreshing your tables project-wide, for example, after a major revision. For the final part of the demo, I will show you eBase, our tool for reporting, materials, interconnections, cross-referencing, and many other reports. eBase is also used for project-wide edits, for example, find and replace by part number, project-wide wiring, or even table and wiring diagram refreshing. To generate reports, simply press Compile Reports. When doing reporting in eBase, you will need to select the reports and report types that you require. You can choose to have the reports stored in your SQL database or stored on DBF files in your file system. eBase provides a button that initiates a refresh of all tables imported to your drawings. eBase also provides a tool to export drawings to simplified DWG, DGN, and if required, PDF files. PDF files can be assembled into a multi-drawing PDF pack. eBase also provides access to the Global Editor, which can be used to do project-wide editing. The eBase Global Editor allows you to step through the drawing to database transfer and edit or modify your data at any step of the process. Stepping allows you to use Excel and other data tools to modify your data project-wide. Project-wide Find and Replace is provided within the eBase Global Editor. eBase also provides a button that initiates a refresh of all wiring diagrams within your project. I will now compile the reports and then take a look at a few of them. In my project folder, the reports are stored as individual files. eBase provides easy access to this file system folder. Firstly, I will examine the Bill of Materials report file. This report contains every component that I've used in the project, including its tag name, the catalogue number, its manufacturer, and various ratings. Now let's examine the Bill of Materials summary report file. This report contains a summary of every component type that I've used in the project, including its catalogue number and its manufacturer. Importantly, the quantity of each component type is also provided. Next, I will examine the cable schedule report file. This report contains every cable in the project, its cable name, its catalogue number, and its manufacturer. The termination devices of the cable and many routing properties are also provided. eBase can also generate formatted reports. The format of these reports is completely customizable without programming. You can change the look or the content by simply pointing and clicking. This report contains every cable core in the project, its cable name, core name, the termination device, and terminal. This data could be used to terminate a cable. This formatted report also contains a cable schedule. In the formatted version, the cables are grouped by destination. A point-to-point panel wire list is provided in the EDS reports. This is useful for panel manufacturer. Your wiring team can fabricate from a wire list much more easily than understanding and searching through schematics. In formatted reports, you can obviously change the fonts, colours, spacings, and the general layout. However, you can also filter and group the data. For example, you could list only the instrument cables in the water treatment area. Similarly, the formatted materials reports can group components by area, panel number, or functionality. The next report I will display is a materials quantity summary report. I examined the unformatted version of this report earlier. The final report I will display is the PLC index report. This report contains all of the I/O details for each card in your PLC. The information includes rack, card, and I/O channel, as well as any I/O asset details and cabling information you wish to include. So to recap, I've just shown you the production of 5 or 6 drawings and more than 10 reports with component and data editing and problems resolved, all in under 45 minutes. Some of the features and benefits I have demonstrated are an integrated database giving a higher level of accuracy and less chance of error or rework, a highly productive set of library, drawing and editing tools, automated error checks, navigation, cross-referencing, component naming and table creation, all of which reduce the chance of errors in your project. An automated wiring diagram system which greatly enhances productivity and accuracy when delivering your projects to the wiring and termination team. Catalog specification driven data, again reducing any chance of data errors. An automated report extraction system which elevates your accuracy and improves your productivity. All of those accuracy gains are summarized in this diagram. If you are making less errors, you'll have less rework, your project will take less time and will cost less. Similarly, if your efficiency and productivity are elevated, then your project will be completed faster and cost less. Thank you for watching the demonstration, and please do visit our website and ask us if you wish to get more Electez information or a more detailed demo.